Good morning to all Wikipedia and YouTube viewers. Today we are going to see about one of the fastest and efficient sorting algorithm called as merge sort algorithm. This merge sort algorithm is fastest when compared to all other algorithms. So it works by three basic principles. First thing, it divides your larger data into a smaller sequence and then it will perform some sorting action. Then finally it will merges all this smaller segments into a one sorted array. So this sorting technique is called as a divide and conquer technique, and it is also a stable algorithm which will maintain the order of your insertion, order of your data when one or two data have the same element, and it is more applicable, it is more ideal for larger data sets. So in implementation of merge sort algorithm, there are four steps. Is the first step is like you should call a merge function, that is like merge sort function with your input array. Within that, we will be performing three different actions. First thing, we will be dividing your input array into subarrays until you will get a one single smallest element. Once you got a single smallest element, which means that your array cannot be subdivided further, then we will be performing some simple sorting algorithm by swapping. This swapping gives you the intermediate sorted result, and that sorted results will be called as a conquer technique, and this sub arrays which are in sorted array, finally they will be merged back together to form a fully sorted array. It works by a concept of divide, conquer, and then merge. Example, let's say that we have an initial array of 5, 3, 8, 1, 2, and 7. We will be splitting this dividing this array into two halves. Let's say that first half left half and the right half. Left half we are going to say it like 5, 3, and 8, and right half we are going to say it of 1, 2, and 7. Now again this 5381 will be divided in 538127 will be divided into again another two halves. Let's say that 538127, and this we will be performing some sorting algorithm. Then let's say that if you have a subarray called as a 5 3, then if you try to sort it, you will get the values 3 and 5. This 3 and 5 again you will be performing it like this. It will goes on until all your data is getting sorted. So we will be performing dividing and then performing some division until you get a single element. Then you will be merging. So it will works by a concept of divide and conquer technique. Conquer technique is nothing but merging all your intermediate result into a single standard final output. Now, basic three things you should remember about merge chart is like it works by a concept of divide and conquer. Second one, it will use this divide and conquer technique recursively. It will recursively split your array into a smaller subarrays until you get a single element. Finally, if you get a single element, then you will be performing some basic swapping to get an intermediate result. This will be repeated, and final result, all the sub result will be merged into a single standard outcome. So why we use merge sort? Because first time it has a good time complexity, it has a standard space complexity, it is a stable one, and its worst case performance is still faster than the any other sorting algorithm. So it takes a time complexity of order of n log n, and then it is very stable. Merge sort is a stable sorting algorithm, preserve the relative order of equal elements. Its worst case performance is still faster. It is also have the same runtime as order of n log n. How much your data sets may be, how much your data array data length may be, it will always sort in a standard faster performance order of n log n. So it will take a maximum of order of n. If you have n number of element, it will take a n memory spaces to complete the process. Now where you can use it and how it is better, you can have a comparison. Bubble sort, its average best and worst case runtime is order of n square. QuickSort and merge has the same equal performance. So in QuickSort, average time complexity and best case is both is order of n log n. But when it comes to worst case time complexity, merge is always the topper. It will have a worst time complexity of order of n log n, and then space complexity of our bubble sort it will take about order of 1. QuickSort takes about order of log n, and space and merge takes about order of n. When compared to memory utilization, merge was little bit higher than the other two, but when compared about the performance, merge was the fastest among all other algorithms. Where we can use this merge sort algorithm, it can be very effective when you are implementing this merge sort algorithm for a linked list. Especially like in linked list, what we use is like your data will be stored in a discontinuous manner. So wherever your data are not stored in a continuous manner, you can go with the merge sort algorithm, and it is more useful for external sorting algorithm to sort your data into a large data set. What do you mean by external sorting? Is like your data may be available in a distributed storages, distributed systems, where you are going to sort your data from each system, and finally you are going to merge into a single standard output. And it is stability in sorting. Merge sort maintain the relative order of records with equal keys, parallel processing. Since we are using a divide and conquer technique, all these arrays are divided into a subarrays, and each subarray can be sorted parallelly. So, which means that your runtime efficiency will also be improved if you use a concept of parallelism. Why we need to have an external sorting? External sorting purpose. External sorting is specifically designed for handling large data set that cannot be fit into a single memory unit. Let's say that you want to store 1 million records of data into a single system. It may not be possible sometimes. For that, what we do, like your data may be stored in a distributed storage locations, and you will be using a networking concept through connect all those distributed data memories into a single unit. Then we will be performing merge sort techniques algorithms. So it is effectively used in computer science, especially for database management, data warehousing, and big data analytics. For big data analytics, merge chart was one of the major and basic foundations for performing big data analytics. Merge chart works by a concept of divide and conquer. Big data work by a concept of divide and conquer also. It works by a concept of distributed concepts. Thank you. We will be seeing about how merge chart works for a sample input.